My name is Carl Chesser. I'm going to be talking for the next 30 to probably maybe 40 minutes about diagnosing your lethargic JVM. To get it started, there'll be a brief introduction. One about myself. I've kind of delved with doing development, interacting with the JVM for the past 4 to 5 years. Most have been through many unfortunate events, a lot of confusion, and I've tried to learn more things about what's happening in the JVM and why things may not be as performant as expected. For those of you who are curious, this is supposed to be a wise fisherman, and that is a fish in his hand, not a liquor bottle. So the first couple things we're going to spend some time on is just going over some concepts. This is supposed to be kind of for if you're beginner to maybe intermediate level of understanding with the JVM. One of the things I like to talk about is thread states. With thread states, you may see that a lot of the definition lies in the enumeration of thread state in the JDK, and so we'll kind of talk about it through these smiley faces. So a lot of times your thread, when it first gets created, it's new, it's happy, it's ready to do some work. It'll then move into a probable runnable state, which many of you may be saying, why isn't it running instead of runnable? I believe it's called runnable because you are enslaved to the thread scheduler in the JVM. So it may or may not be running, but it's really supposed to be doing work at this phase. It can also move into several other phases that we have below. One could be blocked, which has a frowny face because you don't want to be blocked. Waiting, which it could be happening. You're normally working or waiting for something else to occur. So your thread's doing something, and it hands off to another thread, and it's waiting back for a response. Time waiting, you can kind of consider the same thing as waiting, but you've set some timeout. So you said, if I don't hear back from Joe in 5 minutes, I'm leaving. I don't care about him. And terminated, you could have many cases that any one of these states can go right to a terminated phase. That's when your thread dies. I like to categorize some of these states, what we'll label as latency events that are tied to these 3 lower states. So blocked, waiting, and time waiting, we'll call them as a latency event. So something that is occurring in your JVM, but you may not actually be doing real work. You may be waiting for something else that's doing work. The other type of event that I like to call is just a compute event. So this is something that it's in this runnable phase, or your thread is doing some heavy work. You may be computing some very elaborate mathematical thing. You may be just spinning in a loop and doing something very silly. And you may be stuck in this compute event. So when you look at the JVM, you're trying to understand what's going on. Why is my app not that responsive? I usually try to break it down in 2 sets. Either you're doing some actual work, you're on that CPU running cycles, you're doing something. You may be doing something inefficient, but you're doing something. The other one would be the latency event. You've asked to do something, and something else may be handed off and doing something somewhere else, or just waiting for a response. So you're literally sitting there waiting. Now, these are 2 kind of things that, as we'll go through this kind of exploration of trying to understand what's going on in the JVM, try to think of these 2 things to look at. Is my actual JVM doing something on these threads when we start looking at a thread dump or thread analysis? Or is it sitting there waiting for something else to understand why am I waiting for this other thing? It could be a remote service, and that remote service is causing my JVM to be slow or possibly non-responsive. A couple other high-level things we'll talk about, very briefly though, because these are very crazy in-depth topics that I don't want to get really caught up in, but it's something you need to recognize when you start analyzing times or trying to get fine-grained understanding of outliers in timings when you're looking at your JVM. One of them is around garbage collection. So we'll say GC cycles. When those occur, you can have some significant pauses in your JVM as a result. Another one is your just-in-time compilation. So the JVM is going to be doing compilation at runtime to optimize some of your work. When it does that, it actually can slow down some things in your JVM. So around garbage collection, there's a couple things that I just want to call out. We won't go into depth in this, but these are just things to think about, because as we go through some of this analysis, and I'll show some of the tools that I've used, that it helps you understand that, look, I may need to think about tuning or changing one of these settings to better get some better optimization out of my JVM as a result. One of them is the type of garbage collection you may have configured for your JVM. There are several different types you can set up. So you have like a serial or a parallel concurrent. Or there's a newer one, G1, for how it's the style of how it's trying to do garbage collection. The goal of it is to minimize pauses in your JVM. So if you take it back to the serial, very simple approach, kind of all one pass, it's kind of stop the world, we're going to do a garbage collection, and that's a very large pause window. And a lot of these goals are saying we want to minimize the pause time that we have when we're doing garbage collection. you have to understand if you are seeing some spikes in CPU or costs with your JVM, and you see they're related to garbage collections, you start thinking, well, how am I doing garbage collection? How is it configured on the JVM? Another one that I think is very important to always look at is the size of the heap that you're configuring. Your garbage collection is working around your heap on a lot of things, and how it's kind of moving through different phases as that life of that object may live on. If you kind of understand how GC cycles work, you can think about it similar to how most young objects die. So when something gets created, you have a transactional object or something. It's a very short-lived object, and most objects, as you'll see, don't pass through many GC cycles. Usually the first GC cycle will kill most objects that you have in your path. But your size of a heap could cause problems. And the one of them is as you start getting up to or getting a closer threshold of the size of the current heap, you may have to do a garbage collection to then clean up all that waste. Well, the larger the heap you've configured, the larger window that you could have for pausing. So many times you may want to size your heap very large, and that can also cause a combating factor of, well, I might not be doing GC cycles as much, but if I do, they could be large events, and they could take some time. The other factor is when compactions occur. And this will get down when you start really looking at kind of the GC cycles, as well as when do compactions occur based off fragmentations of objects when they're being assessed. I typically never look at this, but it's something to keep in mind when you start getting down to GC style type analysis. From this, we're not going to talk about GCs much beyond this, so you should be very happy. You can applause now if you want. But this is just something to keep in mind, that when you start looking through it, it's a very in-depth thing. If you start Googling this, you'll see that it's an overwhelming amount of information. But it's an important thing to analyze, and we'll show some stats of when you may see or have to analyze these aspects. The other one I mentioned earlier was the just-in-time compilation. I typically never look at this when I'm trying to assess performance, except when I start seeing outliers. And this usually comes around when you're running stuff against what I would call a cold JVM. Something that you just started up, you haven't given that engine enough warm-up time before you speed down the highway. This is running cold, so there's not a lot of stuff that's been compiled yet within your JVM. So what we're kind of referencing right now is the HotSpot JVM, which the name HotSpot is where they've tried to optimize a lot of areas in your as it's running to say, here's a hot method or class that's being used. I'm going to optimally compile that at runtime so it runs much more performant than how I have to interpret the bytecode. When you start looking at some of these statistics, and I'll show you some data how you can pull it, you can start seeing how much time you're spending on compilation. So when you cycle that JVM, you're going to pay some of these costs again. And for the most part, they're not going to affect a lot of your times, but if you're sort of getting down to trying to measure why did it take longer on this transaction, you may want to correlate it to some of these just-in-time compilation events that can occur. Another thing I think is very important that some people forget, or when it comes to investigation, is that you want to capture as much evidence before altering the environment. So if you think about your favorite crime show, wherever it is, and you think how good the normal crime investigators, and they walk in there, they keep it, no one's coming in, they're not messing up the crime scene. And that's how you should look at it when your JVM's not performing well. When it starts having issues, collect as much data as you can while it's in that state. While it's very lethargic, it's not working well, don't stop it. Don't say, well, okay, let's get this thing running in another environment. Try to mitigate that by maybe if you had a proxy, moving that traffic somewhere else while you try to diagnose it before you shut that JVM down. So some of the tools we'll mention here in a little bit are around when it's starting to get in that state, collect all these stats before you stop that instance. And another kind of last thing for this introduction is around JMX. I won't go in a lot of details of what JMX and how it works, but for those of you who are familiar, JMX is a very important tool when it comes to diagnosing or trying to measure things in your JVM. With a JVM, you can enable JMX for remote connections, and we'll show an example of how to do that. This is very important to use when you start. A lot of tooling relies on, if you're going to optimize or analyze something remotely, JMX is extremely helpful. So always think, use JMX when you can, enable it when you can. So the first command we'll start going over is called jcommand. So why would I use this? Jcommand is a great console-based type utility that if your service is running or whatever JVM you're trying to analyze on another node, you can run commands on that host with jcommand to assess and pull different types of stats off the JVM, as well as actually change the JVM if you wish. And when you want to do this is whenever you want to gather any type of state or change something of that state. And this is another kind of piece that's been inherited from JRocket. So Oracle's kind of beefing up their HotSpot JVM, and this was a feature tool in JRocket that's being included in HotSpot. So jcommand, if you just run it from the utility, it gives you a response back of PIDs, so process IDs, as well as those JVMs that are running. It's also kind of showing the main class that's running on it. If you're familiar with JPS, the more legacy type tool that's part of HotSpot, it does the same thing. So you run this, you can find out what other JVMs are running on my host. And that gives you then a little frontier of what JVMs you may want to attach to. So jcommand has a lot of different options. It's always advancing what kind of features you can do with it. So the first thing you do is always run jcommand, the process ID that we would have seen here before, and ask help. And it'll tell you, here are the options you can do on this JVM process. Gives you kind of a larger listing of things that you can do. The first time you'll use this tool, you'll see an error like this, and you may not know why. This is because when you do these type of operations, you must be the same OS user on that host. So in these examples, we're kind of going through as running on Red Hat Linux for what I'll be showing. If I'm running something on a user, which is called Carl, that runs down that JVM, I have to be Carl who's running the jcommand. This is because jcommand can cause a lot of things. I can create thread dumps, I can heap dumps, which you can get a lot of drastic changes from the JVM, as well as you can acquire information about it. So you have to be at least a legitimate user to do it. So if you see this, it's not intuitive, but you need to be the same user. One of the first things that's not a real well publicized about this command is this kind of hidden option. It's called perfcounter.print. You can give this PID, so when your JVM's not running well, this is a great way to first collect a whole bunch of information, all in text, so you can attach it to your bug before you start doing other work. The stats you get from it is a huge listing, which I didn't want to put in. It probably been about 47 to 54 slides of text to save you from that. Here's a couple examples. So from this, I can get a lot of how many threads are currently running, what were the live peak, how many were started throughout that lifetime. It also gives you a lot of details about GC cycle flow. So I said I wasn't going to talk about any more garbage collection stuff. Well, I lied. So it also can give you information. It goes for each phase. So as it kind of how much, what was the sizing for it, and it also gives you labels of those windows. I never normally look at this much data when I'm first analyzing it, but it's an example of how much depth of data you get instantaneously in nice one big blob of text that you can save and start further diagnosing it. Because again, we want to capture as much of the state right up front. Another very important thing that you probably are familiar with are thread dumps. That's a very important thing when you're trying to assess what's going on in my JVM. With jcommand, you can do the same thing as what you do with what was called JStack. JStack was another kind of legacy type tool that's still part of the HotSpot JVM or JDK that's included. Jcommand prints out a thread dump. It has similar options that JStack had as well for getting details about that thread dump. And jcommand also gives the ability, which you can do several different functions, but this is one that I thought was awesome. So in the case where I have a JVM that's not very responsive, it's doing something, and I want to get some more details, many times you don't have everything set up to gather all the information, right? You didn't enable remote JMX while that JVM is running. Well, with jcommand, you can actually enable JMX while the JVM is running to pull that information. So in this example, I have, hey, here's my one Java process that's running on this host. I can supply that process ID in this command, tell it to start that management service, and then go ahead and, in this case, I'm not setting up any SSL or kind of security around on the JMX connection. I specify some port, which can be any port available on that host, and that way I can get JMX working right away on that existing JVM and then connect to it to start doing more analysis. On to the next tool, which is Top. I assume many of you are familiar with Top, but if you're not, you haven't used it, it's a great console tool to kind of get live information what's running on a host. I use it a lot of times to start assessing what's running on this host or why is my process not running so great. The reason I like using Top is it gives you a holistic view of what's running on that host. I'll kind of go through one example here in a little bit. Your JVM may be running slow because something else is taking up more of the resources. So your code may be fine, it's containing resources on that host, and Top can give you a lot of that data. So when you just run Top, you can say just Top right from the command line. It starts giving you a lot of information. In this example, I'm kind of seeing overall utilization on that host, but I can also see all these different processes, in this case, a lot of JVMs that are running. Now, this is helpful from a very holistic standpoint, and it goes back to where I say, is it a compute event or a latency event? And this is focusing right now around compute event because I can sort by memory, or CPU. So I can say, how much CPU is this JVM using? As you can see, a lot of these are not doing much. But if I were to be having a JVM that's doing a little bit more work, you need a little bit more details to figure out what's the next step. And the first thing that I usually then go is say, well, what thread or what code is being executed that causes that? With top, you can hit Shift-H, and it'll change top to start showing the threads that are part of those processes. And this is extremely helpful. So we'll show in a couple slides later how you can correlate what these native threads are being created to an actual thread dump. So I can start saying, oh, here's a thread that's running hot. So maybe in this case, I have a thread that's running at 4.2%, which isn't that hot. But I can get actual threads being shown in that case. Now, when you start doing this, to see a lot of threads that are also being included, you may want to focus down just to one parent process ID, which sometimes is easier to do when you know this given JVM process is the culprit. I'll use that PID so I can focus in and look at all the native threads below it. So this option, I can do -H to see those, and then -P to say use a specific process ID. So in this example, I want to look at a given process. I'm saying, hey, it's running 9.6% of the CPU for that current JVM. This is showing me the threads. So I'm seeing a thread ID. Now, the thread ID is a decimal number that's being shown on the host. So I want to convert that to hexadecimal. So then I'll run, this is just in the bash shell saying printf to, and I want to convert this guy to a hexadecimal number, which is this 514C. If you do a thread dump, many times you can't correlate what thread was using much CPU. You just see what the thread states are. But in this case, when I do my thread dump, you'll see this NID, which is the native thread ID. So in that way, I can correlate my 514C, which is consuming more of the CPU. I can directly map it to say what was the thread in that thread dump, which we noticed earlier. I can do a jcommand thread.print, and I can see that I can get, oh, it was this. My metrics graphic pickle reporter thread was taking more of the CPU at that time. So this is very helpful to say, look at from the native perspective at the host and correlate it back to a thread dump, which includes that native thread ID. Now I'm going to go against what most people advise for actual presentation. I'm going to go to some advanced slides in the middle, and then we'll back out. Who knows who this guy is? Oh, that's good. I heard some Bob Ross. That's great. So strace. Now this is a more advanced section. I'm only showing it because we're going to talk about some of the basic console tools first. But strace is a very helpful tool that when you're running in Linux, you can start seeing what system level calls are occurring. When you need to use this, very rare scenarios. Why would you need to use this? You need that lower level details of what's going on. And many times you're doing it because you don't know what's going on in your JVM because you think there's something else that's interacting with the system that could be causing some of the performance problems. So many times when I run this, I'll like to show a lot more kind of additional details about that JVM as running, the time, and what kind of system calls are occurring. So I'll specify a certain process ID I want to follow. And here's the kind of the general options I normally include. I'm going to show a quick video clip of what one of these looks like. Don't worry about what's going on in the text. But this is an idle JVM. Nothing is going on in this thing. But there's a lot of, in this case, it's a Netty server. So there's a lot of threads that are occurring, and it's just a large influx of data that's coming through that's hard to follow. So as you can see, that was a lot of stuff. And in that case, it's hard to understand what's going on. That's too much information. Well, the case when we do want to use it is when you may encounter this error. Who's have seen this error before? Yes, it's a terrible error. But it's so ambiguous. You don't know why it happens. Unless you read the first part, you say, oh, it's out of memory, right? Out of memory is what caused this thread from being created. And the fact of the matter is, it doesn't necessarily mean memory that restricted this. It can be a various amount of things. It could be that you've hit a process limit on that host. It could be you hit a file limit on that host. Many things which restrict you from creating a native thread. So this can happen often as your JVM's running. And what's terrible about this type of error is that I like to think of it as like a virus. If you've hit a certain limit which causes a JVM to throw this error, more than likely other JVMs running the same host will start throwing this error as well. And it has nothing to do with the code that's running within it. It means the environment that's around it has restricted it from creating any more threads. So when you see this, you're like, well, I don't know if we hit a memory limit. I don't know what happened. You start trying to collect all this information. You're like, memory usage looks great. My thread usage wasn't that high. What happened? Now we use strace. So when that is occurring, if you can have that event reoccur, or as at JVM still spewing out this error every once in a while, you can use strace to start looking at the system calls that are occurring. So as that whole stream of data is coming through, I usually just pipe it to a file. Make sure that error reoccurs. Capture the file. And then I start looking through the file. A lot of times I'll look for, there's some sig term events that can happen, but normally I'll start looking at errors or other events around it. And one of them is a system call for clone. This is around for threads that are being created. Now clone, I don't know the whole contract or what does EA again or EA again mean. So to understand that, you can write from your console, type man clone, and it will not clone a human being. So what it does do is it gives you documentation. And when you go down to the error section, it says too many processes are already running. In that scenario where we had that error occurring, we hit the process limit on that host, and that's why that error was being propagated. So the JVM doesn't give you a very descriptive error from what's being thrown, but what it does give you is saying, hey, I'm hitting some limit from the system, so the operating system. This allows you to jump in a little more details of why. If you really want to be crazy, you can sometimes run this, which if you're trying to grep across many different processes, so you have many JVMs running that are seeing similar errors, you can run strace across multiple processes. I don't typically do this because it's very hard to correlate, but you'll still have the process IDs in those logs, something you can use. So the next one we'll briefly talk about is VisualVM. So why would you want to use VisualVM? I typically use it as my first class tool because I've used it for a long time. That's always my first tool I grab out of the toolbox, right? I want to start visualizing what's going on in that JVM, start looking at things, sampling across the JVM itself. Very simple, just JVisualVM right from the command line, and you can start monitoring things from another VM. For those of you not familiar, VisualVM kind of was spawned from NetBeans Java Profiler. NetBeans Profiler is a little more advanced, has a lot more options with it, and it has a very interesting ability to allow you to do actual profiling on a remote system. VisualVM does not let you do that. VisualVM lets you do sampling, which is like take a thread dump in a very kind of frequent manner and try to correlate how much is being used. So this VisualVM is a nice tool. NetBeans Profiler has a few more options if you want to play with it. We've used it before to profile things remotely, but what I found is that NetBeans Profiler is a little bit heavy on the instrumentation when you run it. You'll start seeing it. The JVM you're trying to profile is running quite a bit slower. And you also have to start your JVM with a bunch of options, which make it hard to really do it in production. So with this, I have a real quick video clip of, if you haven't used VisualVM, this is a little example of right when you fire it up, you can connect to another VM on it, put in a host. That host then, once it's added, you can then add connections to it. And I'll add a JMX connection. From there, I'll specify what port it's running on. Then it goes ahead and connects. And right when you connect, you can start pulling a lot of interesting details right up front. The first thing, you can see how much heap usage is being used, how many thread usage is being pulled. In my case, I want to take snapshots of the CPU remotely to see what it's currently taking or what is the hot code that's inside of it. So in this case, I'm running it, and as it's progressing through, let's say it's taking on transactions, I can start seeing where some of the more costly times are being taken within that JVM. And as it runs, I'll take snapshots. And snapshots are handy if you haven't done this before. Go ahead and connect to the JVM you're doing it, but normally you want to start capturing, okay, as I'm running transactions from this point to this point, take snapshots, and then you can compare snapshots. So as you can see, I'm taking snapshots over time, and then I can connect, or at least in this case, I'm going to stop sampling and look at one of these previous snapshots, and you can compare to another snapshot. So you can see what was the delta between those two time windows, which is very helpful. And as you can see from this perspective, it's just the threads, which is hard to really get to what's the underlying code. If you go down, in this case, to this little hotspot tab, you'll see where it also breaks down what is the hot kind of code methods that are paired with it. So that, again, that was kind of the snapshot compare. That's a great way to first start assessing what's going on. It'll give you a good kind of coarse indicator what's slow in that JVM, especially when you start taking it from specific time windows. The next one is Java Mission Control. This is where you're supposed to get excited. Yes. So Java Mission Control is a nice tool. Mission Control, if you're not familiar, is also from JRocket. It's a pretty nice tool, but it's even better than I think than VisualVM. It has a lot of nice features that are included in it. Again, a great tool to connect via JMX and start doing high-level assessments of your JVM as it's going on. When would you want to do it? Again, initial assessments, or when you also want to do some advanced analysis with flight recordings, which we'll go over shortly. Again, JMC right from the console, and you get this pretty elaborate window that starts up with some fancy gauges that kind of go back and forth. They show you a peg of where the max level is at and then where it's currently running between, so you can see how, just from your given CPU or memory usage. You also watch your memory as well as how much is being utilized from the CPU. Those are all standard graphs you see. But what's nice about Mission Control is that any attribute you have that's in an MBean attribute, you can chart in one of these windows without any trouble. You just add to this little toolbar window, and you can select any other attribute. So if you have some other statistical type or metrics instrumentation, you can then go ahead and graph against those values, which makes it very helpful. You can also do this too with, if you're familiar with JConsole, when you fire that up, you can always double-click on something, and it'll start charting it in a little tiny window that's hard to see. This makes it a little bit better. You can start seeing trends and trend lines with it. Another thing that's nice about Mission Control is that it has a concept called triggers. A trigger you can set up for different types of attributes inside your JVM. So as it's running, you may say, you know what, it spikes every, 10 minutes, sometimes 15, but I don't know what's happening with it. So I'm going to sit at my desk. I'm going to try to catch it right when it happens and get some logs. Well, that's pretty hard to do. With Mission Control, you can go ahead and as it's analyzing it, so it has some general ways of saying, hey, here's some high-level process utilization or whatever kind of high-level attributes you're looking for. You can do the same thing with any other MBean attribute, so how many failures are happening or how much heap is being utilized. You can have it cause a trigger to do some type of event, which this is fantastic, because then you can now do an application alert, so it'll literally pop up in your window, say, hey, this is happening, I've hit this limit. It can send an email, so you can set up an SMTP server and send an email out to somebody. It can also invoke to generate a heap dump on the remote server side. So if you're hitting something, you're saying, you know what, I want to capture what was in the heap at that time, you can have it trigger the heap dump on this point. You can always generate a heap dump on normal events in your JVM, like an out-of-memory error occurs, and you can tell the JVM to throw a heap dump in that event. This allows you to do it when a different type of attribute is being incurred. You can also have it where it logs to a file, which I haven't really found a lot of use for. Also echo out in your console, so if you fired up JMC from your console, it also can pipe things right back to that same console, so if you're just focusing on one window. Another nice thing with it is that you can also watch live gauges of how much memory is being utilized in each phase of kind of these memory pools. This only kind of, to me, comes in handy if you're seeing a lot of thrashing of memory you're using, and when you're previously analyzing your CPU usage, like in VisualVM as well as Mission Control, it'll show you when you hit spikes that are incurred from garbage collection cycles. And that's usually the only time I really care to look at this view, is when I start seeing spikes from garbage collection cycles that are often, which means I'm really pounding and exhausting my memory. Why am I doing that? And you'll start saying, well, wait a minute, I've got a lot of stuff that's collecting in some of these larger survivor space, meaning objects that are outliving that first GC cycle, stuff that I have at a high scope. So now on to Flight Recorder. So Mission Control is kind of a great tool, a lot of other features that are beyond VisualVM. Flight Recorder is very paired with Mission Control. Why would you want to use Flight Recorder? Well, it's a great low-profile option. So it's focused, again, from JRocket, that is, you can enable this option on your JVM, and it'll take between 1 to 2% of overhead on the JVM as it's running, and it collects an immense amount of statistics on your JVM. When would you want to do it? Whenever you want to capture a lot of rich information about that JVM. What's nice about the Flight Recorder is you can think about it just like a flight recorder on an airplane. It's always recording data, and it can do it in a very optimal way where it's writing into this circular buffer. So it's kind of just always writing these data out until, like that, you may have a crash. It can write it to disk when that happens. Typically, when I've used it, I've done it when I want to profile a certain event. So I'm running tests against something. I'll enable Flight Recorder, and I'll do it on demand for a certain time period. So I'm not normally using this option, but it's something that you can use. Now that you know how great Flight Recorder is not free. So free for development use, but it's actually, there's some stipulation I found in some smaller text that's saying that you actually can't use this without licensing. And there's 2 licenses that they call out. Either you can have this Java SE Advanced or SE Suite. So I started emailing around within CernaWorks, and I found out that we do not have this license. I hope that someone can challenge me and say that we do. That means that you can use it in all your development environments. You just can't use this option in production. So when you use Flight Recorder, you do have to enable a JVM at startup. So you have to have these options, and they actually quite certain have to be in this order. Unlock commercial features, and then this Flight Recorder option. And this is only available in the JVM at Java 7, Update 40 that has this option. So you guys, Java 8's out, so you need to at least get to Java 7. When you have a JVM that's running with this option, you can run from mission control. Is one of the easiest ways to start a Flight Recorder data. You can go right in there, and as I had that case where I have a remote connection in JMX, I can click on that JVM, and I can say, go ahead and start a flight recording. It'll go ahead and step you through this little wizard of what things you want to select. Generally select all the defaults, just kind of click next to it, and you can start getting some really great details as you start profiling it. One of the great things I liked is when working through stuff on Millennium Plus, we do a lot of remote connections to other things. One of them is HBase. With this, you can start seeing what other socket read wait times you have just off hosts. So from a JVM that's running, I can see how much time am I spending just on wait events on other type of socket reads from remote services. So in this case, I'm connecting to other region servers in HBase. As a JVM is running for longer periods of time, you can start seeing how much time is it waiting on other certain types of region servers. So you can get down to really great details of just like this I/O. Another great thing it shows is a very good granularity on hot methods or hot code that's being utilized. So before we talked about CPU sampling, and you can kind of see how those are getting measured. With the flight recording, you can get down to really great details of how many times that method is being invoked, how much time is normally taken on your CPU, and what is, how often it's being utilized. So you can start saying, okay, out of my slowness, I can start seeing this chunk of code is causing most of that. Another great thing with the flight recorder is you can get to great details on how much GC pause time is occurring. So out of this event, normally you should see with your garbage collection cycles, as they come and go, it's like a shark tooth, right, as it happens. Your things are collected in a heap, it collects those each time, so you can get a timeline of when those are occurring. You also can start seeing from these points is how much time is being spent on pauses. And that's a great way to start correlating how much time are you spending on GCs that could be affecting certain transaction times. Because if you're talking milliseconds, you're affecting transactions times at that point. Another one that you can use, which I don't normally go too much into detail, is on the compilation time. That's, again, if you start seeing outliers and you don't understand why that's the case, you can start looking at how much time is being spent on compilation. Again, I wouldn't spend much time looking at this, but you can see that I had a method that was being compiled took 920 milliseconds. That's a lot of time. This is probably one of the most helpful options that I've used. So as it's going through, it gives you a discrete timeline of events that are occurring. So as everything is happening, it has each one of these start and end times with it. And those timeline events will also give you how long it took on that thread. So when you're having things that are occurring, you can start what happened in this specific window of time to cause this other delay when I was trying to run something against it. So the flight recorder, as you can see, has a lot of things. One, you can just look at threads in general. You can start measuring general I/O. So most of what I've used is just on the socket read wait times, as well as this event window, which is kind of this last option at the bottom. That gives you this nice delineation of a log of event in that JVM. So kind of to wrap it up, one, I would say always know your command line tools. These are your first front things of what you should use to connect and try to pull any type of diagnostic information. Many times you may say, I don't know what to pull or what to get off it. Honestly, this JCommand tool is very helpful. Just pull those first performance stats first, as well as a thread dump. Get that out of the way so it's collected. And then you can also say, enable JMX, and let's start monitoring as it's running to see what's going on. Always capture metrics while it's being sluggish. You have it at its most weakest moment. Capture it then, because many times you may not hit that same scenario again of why it's not running so well. Use Flight Recorder in dev. So you may not be able to use it in production yet because of licensing reasons, but Flight Recorder is immensely helpful. And more specifically, you can start it up on your JVM when you're running tests and do really deep types of analysis of what's going on. And it has a very little overhead. So Other cases where we've used like NetBeans Java profiler, it seemed quite sluggish when you have that enabled and you're doing that profiling. When you're using with Flight Recorder, you do not notice that. At least I did not in my tests. And as you're going through it, try to classify things. I think it helps to know, is sluggish type results happening because I'm hitting some type of heavy compute event, or is it because it's something of latency? And many things that I've had to troubleshoot, it's not in the compute category. I don't have someone who ships some code that's in my assembly that's doing a lot of just intense CPU all the time. I have stuff that's usually waiting on something else. And so therefore I'm saying, okay, I'm typically waiting on this other process or this other remote service. Why is that? Now go look at troubleshooting of that flow. The CPU side it happens, but from my experience, that's not what I've normally had to troubleshoot. And that's it. So if you want, we have the voting options, which you guys are familiar with. If you do have a -1, there's a gray bin that's outside. It's called trash. You can throw it in there. The plus ones go in the green bins. Any questions, I guess? Yeah. Or, if yeah. Yeah, I can repeat it.
You mentioned JRocket. What is JRocket, and is this all required for Java 7? I think I missed where you explained it.
So JRocket is something that Oracle acquired, so it's another JVM. With JRocket, these JCommand, Flight Recorder, Mission Control, those were part of that, and they now are part of HotSpot. So essentially, as long as you're on Java 7, you get a lot of these features because they've re-included those into HotSpot. They try to make HotSpot the great single source. Yeah. Oh yeah. So some of these all of my notes are around the Oracle HotSpot JVM, but the question was how many of this tooling's around with the IBM JVM. I have not looked into that much. Though when I have investigated stuff, there's a lot of great diagnostic tools I have seen from IBM. I just haven't used them that much. So yeah, from my experience, it's mostly all around HotSpot. I can't speak too much on IBM. Any other questions? All right, well, thank you very much.